Okay, so I guess we can just head right into the panel, if that's a good time. Is Dasha here?
Yes,
Oh, yeah, okay, great. Okay, gotcha. Okay, great. So this is it's something we've been doing all week, kind of after these the series of talks that we just heard. We now have an opportunity to kind of step back a little bit and try to kind of touch and connect about the issues that were raised over the course of the presentations this morning. And I think a lot of themes came up that kind of each of the speakers brought in a different perspective. And so what I'll do is I just have a couple questions. Maybe we can go around the panel, and we'll invite the sort of students to chime in and ask questions really whenever. So if something comes up, please feel free to raise your hand, and you'll have time at the end to kind of let the discussion go where it seems most useful. But so I guess just to get things started, I think one thing that's come up a number of times today is this question of, science is getting bigger, and there's this kind of mystery of, where's all that effort and productivity going to, right? It doesn't seem to just be papers. And there's also this observation that more people are moving from research into industry, and that maybe a lot of the creative effort and productivity is actually kind of being output in ways that need to be measured differently. And I guess, how likely is it that we'll be able to come up with something that's as simple as publication count or H-index? Not that I want there to be H-index, but since it is something that we can grasp and it's relatively low dimensional, I'm just curious if, given all these observations about what science is doing these days, is there some other useful sort of metric that we could start looking at? I don't know if anyone wants to jump in, or I can name names.
I don't know, like I presented first, so maybe we can start in that order.
Great.
I'm not aware of anything that is as easily available. Having said that, there are big databases that are openly available on patents or patent data, but then there are lots of issues around patents in terms of how long it takes to get a patent, how again significant patents are, like how much. So for the very significant things, people apply for them in multiple countries. And there is a line of work that has been doing that already, although I know that some of the more recent, so some of the embedding methods were applied on patents as well, which is not simple. Again, it may not be a simple metric, but that's one that comes to mind. So Bruce is, I think, more likely to think about that, because that's more in the realm of economics, and they were much smarter than like information people on how to gain stuff from that. But the only thing that comes to mind is patents.
Well, I was hoping, Tasha, you were going to answer the question. Maybe Jen will answer it, because it's a great question. It's a tough question. I mean, I do think, the key is, as I just said in my question, speaking as an economist, we incentivize what we can measure. And so you need to be careful with what you measure, because if you measure it and incentivize it, you're going to get it. Whether if you incentivize the quantity of publications, you're going to get a lot of publications. Whether they make a difference on anything or not, you're going to get them. I mean, people respond to incentives. So I think figuring out ways of cleverly measuring the full range of things that we want to incentivize, including production of data, I think that's a huge thing. I guess to some extent, maybe as we see more people using their science for commercial activities, maybe it becomes somewhat less important in the sense that if I start a startup or I license a technology to a company, in some sense, maybe I'm being incentivized through the, through that channel directly. And I mean, my institution may want to measure that and say, hey, good job. This is good stuff for us to have done. But part of my incentives may be coming through, through the market. But this is an incredibly, there's no question that this is an incredibly hard problem. And the part of the problem is people, as I say, are responding to the incentive. People respond to incentives, and you can't really incentivize very well what you can't measure. Or if you do incentivize stuff that you don't measure, you wind up, generating, very biased, oh, well, we'll, these groups are the groups who must be doing well, so we'll give them lots of gold stars for it when, objectively there are other people who are doing, as well or better.
I also want to follow up what Sarah, right? Is that the name? Can't see it clearly. No, Stessa. I'm sorry. Since you brought up the subject of patents, I think I can share some results from our research. We did collect some patents data because some GenBank annotation records are related to patents if that DNA sequence was involved in a patent application, and the patent ID can be linked back to the GenBank record. So in our research, we discovered, by just sometimes I like manually to check how this kind of relationship is, how they are related. So in some cases, when I manually check the patent application, I notice one patent application may involve like tens or hundreds DNA sequence submissions. So that, and also the number of authors in the patent application and the number of authors in the data submission, well, the names are really overlap. So, which means the names appear in patent application are not necessarily those who who actually did the dirty work. But if we consider patent as a innovation or as a new discovery, then we can say this new discovery or the new knowledge is supported by a large data production activity, large scale data production activity, because hundreds of DNA sequences is not trivial. And of course, modern sequencing technologies has greatly reduced the time and the cost in sequencing those genes or RNA or proteins. But at least we can, if we measure, we just count the number of submissions, or and then we can say the scale, the size of data production team, or the amount of data that produced are increased over time in order to support a new discovery. And we also studied the time gap between data submission and the application, patent application, as well as data submission between the gap between data submission and the publication. And we discover over time, the time gap has been narrowed for both the publication time and also the patent application. So that is, I think that is a measure at least at macro level that can, we can tell the science policymakers, say, see, you invested a great, amount of money on building the cyber infrastructure. Now you can see the result. It does accelerate the knowledge diffusion or the new discovery. So I think the measure, sometimes we do need to differentiate between whether it's to individual persons or to at macro level, at economic, the whole level, and also whether for researchers or for the science policy, how effective the science policy is in terms of promoting new discoveries to save time, save money, and bring better treatment for the society. And so I think there are different levels of the measures. So we cannot just say, oh, the count is, and we also need to evaluate, the entity that make all these funding and decisions and make the policies, whether they did it right, how well they did. And that's another aspect of impact assessment.
So the conversation of patents, and one thing that makes me wonder is what it looks like is that all this government-funded training is sending people out to work in industries that are doing public good, right? Making medicines, developing new treatments, but they're also making money off of it, right? And so I guess one question is there an argument that industry should be supporting training more or supporting research more? Because obviously you got to have universities to do basic science research, and I know a lot of in certain fields, companies will pay for their students to go back to school, for instance. But I guess if that's really who's benefiting, is there an argument to be made that there should be more support from industry just kind of back into the training enterprise? And is there any way that argument could be moved forward?
I mean, it seems to me, that's not something I've thought about deeply. It seems to me that the industry, as I understand it, the industry support for research is strongest when there's a direct link between a particular lab's activities and that funder. And I'm sure at many of your institutions as well. But at Ohio State, there are companies that are looking for solutions, and there are labs that have the ability to produce them, and they're getting supported by those companies and writing contracts to provide the research back or to make it available, and then those companies are hiring grad students and postdocs and undergrads from those labs who really are trained. It strikes me that sort of at a broader scale, that maybe the connection, that the connection between a particular individual's research and a particular business is probably is too uncertain, that it would be probably hard to justify on a specific basis. Now to say, look, this is something that we as business writ broadly need to support, because these are the types of businesses that are requiring these types of skills. And, either we don't want to ramp up on H-1Bs and other forms of immigration, or we don't think it's politically feasible, even if we did, so we need to train more folks domestically. That I think is a different story, but it seems like that's a different argument than the sort of the more immediate one, which seems like there's a constant matchmaking activity to say, okay, how do we hook up the right labs with the right businesses? But beyond where we're going, I don't know how much deep, I don't have a clear sense how much deeper we can go into that pool without more structure on that.
Yeah, I totally agree. And the one thing I think, if you think, should they fund more the training portion, the way NSF now wire like grants, like a lot of money goes towards grad students. So it's more like the way Bruce said, there are lots of contracts for research and they probably find students through that. But I think the logic is that by having this really well-trained workforce move to industry, the economic welfare of the state goes up, then the tax money trickles back to education ideally. So I think the logic is that maybe implicitly by having them benefit, they pay back through other means, but not necessarily like giving money for education. I mean, I think I'm not an expert in that, but I think that may be the logic.
Right. So I guess so maybe it's, and maybe this is already being communicated. I guess, one question that kind of has kind of come up a few times in the course over the past couple of weeks is, science of science, we as a field, how can we communicate to policymakers in a way that's effective, and how are we doing a good job as a field, or what could we be doing better? And I guess, here's an example maybe where, okay, in addition to kind of basic science, we're producing a workforce that's kind of helping the economy, and that's, maybe that message is already clear, but I guess, is there more that science of science could be doing to kind of help the government, or should we not be talking too much because we'll confuse them or something? So.
No, I think that's I think that's a critical role for us to play. I mean, I think, all of our institutions, I'm sure, commission economic impact studies, and those are a dark art. I mean, that's something from like a Harry Potter novel, where we've got these multipliers and all these cast these certain spells, and it's I mean, I think one of the things that we've tried to do with U-Metrics is to find very simple, very transparent, very communicable statistics, like this is the share of graduate students who stay in state, and this is how it varies across fields, and this is how much they earn, and these are the companies that they go to. And because I think we've, not necessarily science is science, but I think research institutions have produced these kinds of reports, and they've used all these very non-transparent methods, and state legislators and members of Congress and their staff, they may not understand all the methods that go into producing those reports, but they're smart enough to know that when you take a number and then you wave your hands and say, oh, but now I've got to multiply this by 500, that something, that something just happened, and it probably reduces the credibility of what it was. And so I think, for us, we have that ability, and really using simple, straightforward, transparent, things. And we do that for U-Metrics. I mean, that's one of the reasons why I think member institutions join, in part because they think this is important for advancing knowledge, and they want to support their researchers who are using the data, and they want to have this knowledge. But we also produce reports that get handed to institutions and that they can use with, you know, members of Congress and their staff and state legislatures, and you know, and the people we talk to say this is very effective, that those folks appreciate that this is a very simple, straightforward, transparent way of communicating the value of these investments. And I think the further we can push it down, I think the more, you know, going back to your previous question, the more we can say, you know, not just these are the number of people who got jobs and these are the industries, but, you know, here are the advances that they produced, and here's a plausible counterfactual for what would have happened if that hadn't been done. You know, I think the more of that we can do, you know, I think that's absolutely a role for us. And I think, and part of it is, I think we need to also be willing to say when things were duds, right? I mean, not everything, you know, not every startup turns out to be Amazon, but, you know, you know, and so they're, you know, saying everything's a winner, that's not necessarily the way we want to focus our thoughts. But, you know, but we also need to be willing to say, you know what, this one didn't work. And we need plan B on that particular one.
I think that the U-metric is definitely like a great tool for individual, maybe institutions to use when they communicate. I have to share, when it comes to Science of Science research published in, you know, like journals and conferences, I think at least I had a really naive view, and that's not that, well, if you gain knowledge of how system works, right? If you understand the processes as a funder or as a policymaker, you can take that into account when you make the decisions. So it's more naive or idealistic, right? It's like when physicists come and study science and have all of the assumptions on how it works. But I've heard, so I've been at a few meetings where there were actual policymakers, and they said, well, that's not how it works. As a policymaker, what happens is there is a particular date, there is a pool of money, and the only answer to that is how I divide that money, which is an immediate need, right? It's a different need. I need to divide this money in 3 weeks. And then I think lobbying and using, so maybe I think if you use data that is produced by U-metrics team or other good teams, maybe that's how people lobby and get the money. But I think the questions asked by Science of Science research community and the answers needed, like, and the questions that policymakers have are not the same questions. Therefore, the data is not as easily applicable. So, yeah.
Yeah, and so I think another thing that again, kind of to echo some conversations that came up earlier this week, you know, I think certainly among this group, there's a big priority around the kind of social good that we can do as a field. So not simply just, you know, kind of building up the research engine and enterprise, but actually kind of addressing some of these issues around equity and representation in the field. And I guess maybe it's nice to hear a little bit more about has the kind of, you know, these policy level, you know, sort of very large scale assessments of the field. Is that can we use that effectively to sort of advance these sort of other kind of not purely money oriented agendas?
I mean, I don't know if either you want to respond to that. I mean, I think, you know, I think it's a bit, I mean, I think we need more of these, or tuned slightly differently, schools such as these. But I think it's a really bizarre thing that you take someone who runs a lab where they're doing amazing science, and if you think about what it takes to publish an article in a frankly, if you think of what it takes to publish an article in even a crummy journal, it's amazing the amount of care that goes into that, right? And then you think about, well, what does it take to publish an article in a really good, like that's just a staggering amount of effort and thought and care and design and thinking through pitfalls and responding to things. And you take the people who run those labs and you make them a chancellor, or you make them a dean or a president, and all of a sudden, after decades of doing that, they're making decisions based on war stories and hunches and gut instinct. And I think, you know, I don't know if it's a failure of what we're doing or if it's just an opportunity of what we're doing, but that is like nails on the chalkboard, right? I mean, that is just, somehow we need to find a way of, and I'm not sure that I have the answer to this. I mean, I think part of our hope with U-Metrics, which I don't know that we've been as successful in, maybe we will be, is to start thinking about how to use science to inform those kinds of decisions by those kinds of people, because you know that they're interested in I mean, you know, this is where they came from for the most part. Why would they want to stop thinking in this kind of a way? But I don't know that we've given them all of the answers that they need, or maybe we're not communicating it, or I don't know. But somehow that seems like a huge opportunity for us. I think, you know, my sense is that, you know, that NIH has gone fair, you know, so so the universities seem to be there. My sense is that NIH is much more keenly interested in trying to use science to think about how it can do what it does better. I think my sense that I have less experience with the administration at NSF. It seems like NSF's administration, either they don't like me, or they kind of have their, you know, they do things more internally or what have you. But I think somehow this is something, this is part of the promise of what we do, is to, you know, learn what we can scientifically and help people to do what we do better. And I don't know that that potential has been fully realized yet. And maybe other people, I'm sure we could find examples, but I'm sure, I feel like there's a considerable unmet opportunity there.
I agree that I think it's underutilized. I think maybe messaging or targeting the messages out of some of these studies in a digestible story-like way, because they like stories and you could tell stories from supported by data, but I don't think that has been utilized. One thing that, Bruce, you did say, which really struck me, and I think that may be a way forward, which is when you said, you present the data and then you ask the question, but look, if we didn't do this, right? It's counterfactual, which is modeling or simulation. And I think that is definitely underutilized because, and I've recently read that there is no there, meaning that there is no true science policy which is thought through. It's more ad hoc decisions that were made on past problems. We had a problem and we solved the past problem. And now we are using those policies, but we didn't have systematic, like, can we envision this? Where can we model it? Can we see if we tweak this system this way, what are the potential outcome? And do maybe some of the stuff that I know you wanted to do, and Pierre as well, like more kind of like simulations with maybe experiments. And I know it's not popular, but there are, I think, a way to test the system or like try and see, can we make these policies that are forward-looking and not ad hoc reactions to past problems, which just because of the preferential attachment and all of the things we've mentioned, they just create totally unthought of consequences and like getting system more stratified and crazier, I would say.
I just want to go back to Stephen said earlier about that, you know, federal agencies invest money for whoever does research, and then the research produced startup, and then startup went out to form a company, and company makes money. And so how that is how that kind of cycle is doing public good. I thought this is, if the federal investment can produce, investment can help produce more startups, and then even though those startups, succeed, make money, and on a whole society level, this is still good, and this is what I think that the government would like to see, or their role is, is to bring prosperity to the society. And on a macro scale, and this is, I think this is kind of a cycle should be considered as a healthy, but because, if the company makes money, and they'll have to pay taxes, and those taxes go into the federal fund, and then which can come back to support research and etc. But I think doing this, doing all this, is not so much on the science of science. I don't know how to say this in a nice way, but I do think for the science policy makers, they do need to have some measures or constraints for researchers receive funding to, or for researchers in general to pay attention to the society, the last category, the benefit, the B part in that impact equation. And this, we all know, for this is extremely difficult to measure, because the benefit, the societal benefit is not always easily, the data in the first place is not readily available. And the second, even if it has, and the value is very difficult to assess, and how do you measure, a science project in high school has planted the seeds for this person to get, to become a scientist like 10 years later, to who is going to make a breakthrough discovery. This kind of long-term societal benefits are very difficult to measure, but it doesn't mean, we should ignore or should pay less attention to it. So I think there's, for science of science research, it is our responsibility to first to find whether there's any like transparent and more simple way to gather this type of data, and if we have the data, and how this data can be incorporated into what we already know to either predict, like the model you mentioned earlier, like Stessa and Bruce mentioned earlier, incorporate into what we already know, we already have, to assess the this kind of the benefits. And I think that kind of impact is important for the science policymakers to know, but it's hard to gather right now. It's just through like news stories, anecdotes, not systematic measures. So this is what I want to say, and this can be, I think, for the societal and broadening participation by diverse, population groups, that should be one of the measures in the societal benefits, societal impact equation, but that's something there's not too many research. I think research is needed definitely in that part.
Can I just add one thought I mean, the other thing that maybe we should lighten up on ourselves a little bit, not entirely, but just a little bit, is, policy is inherently driven by on a very different time scale than the research that we do. I mean, anyone who's talked to policy folks, and I get calls from time to time, like, policy is driven by a news cycle, and whatever they're thinking about today, 2 tweets or reports on CNN later, they're focusing on something completely different. So I mean, there is a reality that we are never, like my vision, I think when I started this was like, we're gonna get the derivatives and we're gonna find the maximum and we're gonna set the, like we're gonna really get this perfect and it's gonna just, like amazing. Like there's a reality. We're only gonna get so far. But I do think there are first order things that it seems like, that we have not managed to help these folks, inform these folks. And those are the places where I think, we, I mean, I'm always an optimist, but I'm optimistic that we'll, as we progress as a field, that we'll be able to do better. And I do think, and my guess is that, and I don't know how this structures, but my guess is that trainings are sort of an important part of that, where, I don't know what that looks like, but, we get researchers together with administrators and science policy folks and sort of talk through and get, okay, these are the things you need to know. These are the things that we have. These are the things we can help you, we can think about for the future. But to get this sort of discussion going with engaging those groups, I think would probably be a very valuable way of doing that. Because I know when I've had one-on-one discussions or small scale discussions with administrators, these people, they may be kind of doing things by the seat of their pants today, but they get the value of doing this if we can provide them with the answers that they need.
Yeah, I really liked Jan's invasive species model of scientific outcomes, but I don't know if that's the best thing to sort of tell the public. So I guess just one other thing that may be worth just going back to is the kind of, I was struck by how there was the graph, I guess, as Sasha showed it initially of kind of where trainees are going, right? And this, the depressing statistics, right, about and I guess I'm a little curious about, why are we here, right? Why are we in this weird situation where the enterprise seems to be chugging along, and we seem to be, there are these shifts, tectonic shifts where collaborations are growing, publications are growing. So these things happening that are changing, right? And one of them is this, kind of that, at least right now, I think, and the mentorship data that I've looked at definitely shows that more people are entering graduate programs than can stay in research, right? At least in this sort of classic principal investigator track. And I guess the question is that necessary? Is this sort of some inevitable consequence of just the nature of reality, or is there something about or how can the system, if we want to sort of the system to work for scientists and work for trainees, is there something that we can do? And I don't know if it's necessarily, I don't think this is about like NIH funding this or funding that, right? It's more just sort of the culture of science. And I don't know if there's anything that can be done to kind of make the system less stressful, I guess, for trainees, right? Which I think right now we are in this world where, for whatever reason, it's just more stressful, right? I think there's more anxiety among scientists. And I guess it's just, I don't know if there's anything that you guys could comment on in that kind of perspective.
I know we discussed a little bit in the presentation section about that. I mean, I think we need a better understanding, honestly, of what is happening in the system, because I think now we have a patchwork of like, so we have one picture that you can get from the data, which is that people stop publishing sooner. Then there is another picture that you can get using other data sources. So there is stuff that Bruce has shared, which is the actual employment data, which can shed a different light. And then there is data that hasn't been added to that, which is, for example, Umetrics data, which really shows you type of the things that were posed in the question, like what is the training environment of these individuals, and maybe what is the relationship with the training environment and job outcomes and publication outcomes and other stuff. So my sense is that in order to really understand better this system, we need to utilize multiple sources of data and hopefully triangulate them so that we can really have a better sense of what is happening, and then maybe try and see what would be useful as maybe advice or like policy types of things. So I think that, yeah, we can say that there are pressures on the system and that there are more people entering than there are people who can find jobs that they would ultimately like to get. I don't, but like there is a big but we don't know actually what the outcome is. Like they might have wanted that particular job, they didn't get it, but maybe they really thrived in another opportunity. And again, I don't think we can answer these questions just looking at particular pieces of data that we have.
I mean, yeah, and just to build on that, I mean, I think that's a great answer. I think, I mean, so one thing we're trying to do is to try, with Joe Stout at Census and Gabby Jiang, who's at OSU, we're working at some level on trying to answer this question. And I think one element that I would note is I think it is not monolithic. Right. I think to say, you know, what we think about it is, are we producing too many or too few? I think it's the wrong way to think about it. Right. It's there are, you know, we are probably not producing too few computer scientists. And, you know, I don't know that I want to, you know, pick on a specific field, you know, but we can probably imagine fields where we're probably are producing too many. Right. So it's not monolithic. And I think the question there is sort of, how can we, as Sasha's saying, how can we develop more convincing metrics that will help to inform policymakers and frankly, you know, inform potential students? Like, this is what your likely career outcomes are. I mean, you know, I think we provide more information to people who are subjects in our human subjects experiments than we do to prospective graduate students. That's there should be informed consent when you enter a graduate program. You know, these are the you know like they say about, you know, when you invest in something, you know, your returns may vary. Past performance is not an indicator of future returns. But just so you know, these are the outcomes that people who have entered this graduate program have experienced. But what we're trying to do is to say, you know, again, to go back to sort of, you know, I mean, you know, supply and demand and say, look, you know, which are the fields in which, you know, earnings and earnings growth are high, which are the fields in which earnings and earnings growth are low, which are the fields in, and then I think that's an obvious thing to do, at least for an economist. But then I think the other question that's a little bit more tricky is, when you see people going into industry, is that a good thing or a bad thing? And again, I don't know that there's a clean answer to that question. I think it's the way is sort of more the way you frame things in your talk, Stasha, is, you know, are you using the skills that and the knowledge that you have acquired in your graduate program in your job, right? So if I see someone with a PhD teaching K to 12, look, they may love teaching K to 12, and that's awesome. But for the most part, they probably don't need a PhD. Or, you know, as you gave the science writer story, again, for most cases, you probably don't need a PhD. You know, if I go to work as doing, you know, robotics, you know, I may well need a PhD in order to do that. And as you say, that may be actually a better use of my skills. And if I go to work for Genentech, I may well need a PhD to do that. So I think what we've been trying to do is to say, is to look at the dissertations that people write using ProQuest dissertation and theses. We have the titles and abstracts of people's dissertations, and then use natural language processing to relate their dissertations to the patents that the companies that hire them hold, and say, you know, is your employer or the industry in which you're working using the kinds of knowledge that you clearly possess based on your dissertation? And that's our way of trying to say, you know, monolithically, but for any individual person, is a placement in industry a good placement, or is a placement in industry not a great placement? And it turns out that obviously the people who get jobs at companies that are using the knowledge that they have happen to earn a heck of a lot more on average than the people who don't. The one exception seems to be, you know, sort of the highly quantitative folks who go to work as programmers or on Wall Street, right? I mean, we don't think that hedge funds are, you know, interested in high energy physics. They're interested in people who, you know, have really good quantitative and programming skills. So there's sort of that weird space out there of people who just have skills that industry needs. But, you know, but in general, it's a pretty strong predictor.
Yeah, that's a great point about kind of demonstrating that that's a pathway that actually can provide the sort of rewards, if you want to call them that a research career is supposed to, or promises. So I thought I saw maybe a hand. I don't know if there's a question. Maybe not. Yeah, I mean, these are tough questions, and I think for the trainees here, I think it's, please, yeah, don't feel like the burden of the future is on your shoulders. So there's a, let's see, yeah, a question from Nick.
Yeah, I was going to hold my tongue, but this is kind of the flip of what we were just talking about. So thinking about, you know, job prospects or outcomes for trainees, I think about the flip side. Like, if there is a brain drain in academia, are we left with, you know, the B- students who are creating the literature and trying to move the needle forward, when the best and brightest are looking for better work-life balance, better paychecks, more stability, more geographic stability? Is there a worry that there's not the correct balance to kind of move academia forward in the most efficient way?
I love your comment. I don't think there is not a good answer, because it's, but I've been hearing that more, like, who even wants to get an academic job? And I keep hearing that from more of a trainees, just because, like you gave a lot of reasons why people look at it and say, well, I'm not even sure I want to be that, or I want to subject myself to these sorts of things, therefore I choose the other stuff. But that's where I think more holistic, you're just thinking about, it seems, and I don't have good answers, but we are trying to solve one problem, but then solving one problem may create other problems. It can really knock the system completely, but it's very difficult to think about, like, all of the levels in the system, and maybe competing interests, and how decisions made, for example, by entrants can really create huge outcomes for, I don't know, the whole science in a nation, right? Because you can have a lot of people pack their bags and leave to another country. We had that after the World War II, and we saw what happened, right? Like the power shifts, and then lots of like economics and everything changes. So I don't think there is a good answer, but I do think that we need to think holistically. And one of the things that you bring up is that, like, who stays in academia and what are the long-term consequences for example, the advancement of basic science and training the next generation of science. So great comment.
I think it's a great comment too. I think, again, I suspect it varies a lot from field to field, right? I mean, I hang out with a bunch of physicians, and there I think it's, and obviously biomedical research is a huge portion of the research enterprise, and there, you've got a lot of people who are in clinical practice, and they're, but they also have faculty appointments, so I think, I don't have that large picture to be able to say this universally. I suspect there are fields in which maybe the very best and brightest are leaving academia. My sense is that this is just anecdotal from economics, and the people I talk to is whether the best and brightest are always staying or not, that we're managing to retain a healthy dose of a healthy helping of the best and brightest. I mean, I do think the computer scientists I know say they struggle to retain their best graduate students. It's just that the opportunities are so phenomenal, but I'm also not sure that we produce way more computer scientists than we need to staff the next generation of academic researchers. So I don't know that we're not, I mean, for all of its misery, this is actually a fairly good, in other ways, this is a fairly good job. So, I don't know. It's a good question though.
That's and that's something I think that we don't want to forget, that the stuff is still kind of fun. But so just want to share any other questions, last minute comments.
I have a quick, Sasha, I have a quick question. It's more specific for you, but I didn't get to ask, which is, could you talk a little bit about like how those curves, those sort of survival curves that are really cool that you showed at the end of your talk, like how do they vary by, for the people who attain sort of, primary author status and not, like you said something and I didn't fully catch it while you were talking.
So I don't think that we necessarily made the survival curves but we did the survival model. So like we did the like how long you survive, so the risk of leaving. And when we applied those model, people who never led a paper, so people, and actually we were really generous, meaning anytime in your publication career, if you ever were the first, last, or corresponding author, that was our criteria. And there were a lot of, like, surprisingly 70% of people, which are not just like one paper people, like people who produced, and some of them had a 10-year-long career, never leading a publication. But like we found that these people were at a higher risk of leaving sooner. So if you look like, will they make it to the next year? They are more likely to get kicked off. But the thing is that the distribution is continuous. So actually, even people who led papers and who stayed longer are also at risk, right? So it's just that their risk is not as high. So the thing is that there are two takeaways. One is that it's not by model, right? It's not that if you lead a paper, that's a recipe and you're good to go, and but it gives you a chance to just stay in the game longer. The second thing is it's not a leaky pipeline, also, because what curves suggest is that because according to the leaky pipeline model, there are these bottlenecks, right? There are these stages in the career where you see a lot of people leave. But if you look at that, we don't see spikes. And again, it's publication, right? So for a lot of people, it would be diffused because somebody published like 2 years before they started, somebody after, right? So it's not that they would see it in a single year, but you would see it in a 2 to 3 year window for a cohort, right? But we don't see, so the narrative goes, you are most likely to have a lot of people leave just right after PhD, and then you are likely to see them after a first postdoc, and then after a second postdoc, and then at the tenure decision level, but we don't see those spikes, like we don't see those bottlenecks. So it does seem that this attrition is happening throughout, that like this model that people are leaving just like, hey, now it's my 3 years and I couldn't find it now, it's really not shown in the publication data, which I think is interesting because maybe we should rethink like where the retention needs to happen. Like if you just remember, hey, somebody is up for tenure, maybe I should think about retaining them now, maybe it's too late, right? We should have a more continuous ways or like more systematic ways of nurturing people or helping them make right decisions, because it's not at these particular stages that things seem to be happening.
That's right. I mean, it also strikes me, I mean, I know I'm like, you know, just shameless here, but it also it seems like it would be awesome to get you metrics into this, right? Because then you could say like, how do those people who never attain lead author status, like how, you know, what are their job titles and what are their career stages and so forth. So yeah,
I'd love to see that. I'll definitely love to see that, because that could help shed some of the light. And again, we were open with that. I mean, we were saying like, there are things we cannot see, right? And we don't know what they do. But I actually was really like, if you say the attrition curves, I wasn't so surprised with, because I've seen similar data, maybe not shown in the same graph, but like the narrative was there. Like I've seen at least in 3 papers saying that half-life is 9 years for biomedical, right? Or 13 years. So like, I wasn't so surprised. For me, that was confirmation of like what other people, and it matched what others have shown. But actually that 70% of all of the people never led the publication, I just couldn't be, I was totally blown away. It's like, so you've been 10 years and you never led a paper, and like, I don't know. So for me, that would be really like trying to understand what these people do and where they eventually end up would be fantastic. We should explore that next time.
Yeah, we should write that paper.
Yeah, I'd be very curious to see that result myself. So definitely. Okay. So if there are no further questions, I think we're done. Definitely, it looks like, yeah, we're a little past time. And I know Daniel needs to do some sort of technical operations on Zoom. So, well, maybe I can hand it back over to you, Daniel, I guess if you've got an eye on the schedule and when we should reconvene.
Yeah, thank you so much to the panelists. So,
sorry, thank you for
thank you.
for your talk and for the panel.
So we will reconvene at 1. So it's like 55 minutes. Wait, 35 minutes. Wait. And you just connect to this Zoom, and you'll have like a breakout room just for you, where students will go in and out by themselves. So just join in and join the breakout room. I'll be there if you have any questions. But I have to close this Zoom meeting. And then students are gonna enter. They have 15-minute blocks, and at most you will have 3 students per block, and they will ask questions or whatever related to their own research or the project that they're working on.
Sounds good.
Sounds great. Thank you. There was a question about the name disambiguation strategy. There aren't great. So like Bruce mentioned the work by Wattler Torvik and Neil. That's really a very good disambiguation, but it's only on PubMed data. So if you are into that, that works. If you're using Web of Science, there aren't readily available algorithms, but there are things that people use. I use something called hybrid between only first initial and all initials, which is not ideal, but when you control for the field first, right? So if you start everybody in physics, then you will end time, it's not that bad in terms of the results. So hopefully that's useful, but there are lots of things out there, but not too many readily available algorithms. And it's still an unresolved problem.
Yes.
Great.
Thank
So
you.
see you later then. Thank you. Oh, would you mind?